Tobiason, President and CEO of InnoWaCon, LLC. He's going to talk to us about converting organic content-laden MSW to high-methane content biogas and RDF. And I'm really pleased to hear what he has to say and all the great technologies they have.
Thank you very much, Andrea. Is this loud enough? It's good. Anyone speak German here in the group? You do? Someone does? Well, before I came back to the US, I was born and brought up in Massachusetts, went to Germany, so I decided I'm going to do this speech in German, if that's all right with you. No, don't worry, it will be in English. I did live in Germany for about 36 years, and the last station I was at was, where's the clicker? There we go. Sorry about the delay. The last station I was at the Zweckverband Abfallbehandlung Kahleberg, which is a mechanical biological waste treatment plant in the southwestern part of Germany, and that's what I'll be talking about shortly today. This is actually I should go back to my question. Is this viable, this content biogas and RDF, is it viable? Is it for California SB 1383 compliant? And simply the answer is yes, it is. But why? It is, why? Because of landfilling problems these days, capacity, the siting of landfilling. I think everyone knows it's very difficult to site a landfill these days. The waste hierarchy saying you don't want to landfill much or very little. You want to use the whole waste hierarchy so there's very little at the end. You have to also ask with landfilling, what's the total cost of ownership of that ton? If it's just your tipping fee, is that the real total cost of ownership after 3,500 years of that landfill? Big question mark. With incineration, it's also the same thing. The age of the facilities these days, they're not getting any younger, and they're more difficult and costly to keep up. Siting a new one, you can forget it. I know in Baltimore, they have trouble with the Bresco incineration site. It's been around there for 35 years maybe, and it's causing some troubles there. They've been trying to do different things with it. Also the waste hierarchy, you don't want to incinerate if you can do other things with it, like recycle. And NIMBY, not in my backyard, everyone knows that. No one wants an incineration stack. And another acronym, I didn't put it on this slide, it's called NIM2. Do you know what that is? NIMTOO? Well, that's for the politicians here. That's not in my term of office. I'm sure you can think what that really means. Everyone's looking for a tried and proven alternative. The answer to this is you have to answer all these questions that we were just asking before. What current sustainable future product is there that can take all this material and recycle it and convert it? What technologies are there, out there, available, working, tried and proven technologies? We don't want any pie in the sky and I have a great idea technology. It might work, we think. That doesn't fly here. What do I do with my organics, my garbage, the waste, the nice juicy stuff? What can be landfilled? And what complementary technologies can be used along with this technology? All these questions have to be thoroughly addressed. And ideally, you want a complete solution that'll take care of everything. Combining the collection and waste and recycling centers together, when you do that all together, working with them, and a very sustainable waste process itself. Just can't have something that's going to use up a whole lot of energy, a lot of space, emissions into the air, water, ground, etc. Recycling, it has to recycle. You try to get the most energy, most recyclates out of the household waste, MSW, that is possible, and only dispose of certain things in a landfill that you can't do any otherwise. It should incorporate the complementary technologies that could enhance it, and it should be BAT. Who knows BAT? Best available technology. Should be that, not just state of the art. State of the art kind of stays along the timeline and doesn't follow. BAT always moves with the time. You're always adjusting, making the technology better as time goes on. One waste treatment solution is a mechanical biological waste treatment. It has had in the past many challenges. Some people have tried it out with different processes. It just hasn't worked. I've seen it in Germany, or I've heard about it in Germany. There were 2 plants that were built with another process. Sadly, they failed miserably, and there were tens of millions of euros that were sunk in the ground, and they had to dismantle these plants because the process did not work. They did not address all the concerns that were listed above. They were not complete systems. Some were. Difficult to control and maintain. As I said, the process just did not work correctly. And it was designed and built mainly just good enough to do the job. You can't do that. Because if you're going to drive a nice car that's just good enough to ride on the highway, maybe at 50 miles an hour, but you want that one that goes 70 on the highways here, maybe 80, here in Florida, then you have to have something that's really sustainable and workable. And it has to extract the maximum amount of energy out of the material that you're giving it. And some of these were absolutely not sustainable, resulting in unreliability of the whole plant, non-availability. It wasn't up there all the time and running for you. They're scrambling around trying to fix it. And facilities that could look like this. That's a tipping hall, tipping floor in one place in Germany. This is in the mechanical processing side, and you will see here, these are cable channels, open cable channels. And what are you seeing in there? All sorts of dust, dirt, papers flying around, plastics flying around. Talk about a fire hazard. Cubed. In the drying tunnels, you're seeing people walking around in drying tunnels here. Well, the vapors coming out. It's a little hard to see in these pictures. Here, stacks of material open. You don't want to walk in there. First, you got your feet all dirty, and the smells are terrible. You can see here the vapors. This is a real place where even some of these doors here are cracked open just because they're not working anymore. And material and machines and pumps and things are not situated correctly so you can get to them when you have to change them and fix them. And open storage of certain materials, this is environmentally not sound. Can't be done. So what we did was we created, it's called Maximum Yield Technology, MYT, and it is a sustainable. It is a tried and proven product. It is fully developed, fully designed. It is flexible with the inputs, the different kinds of inputs and the outputs that you have. Mainly it takes MSW, municipal solid waste, with the organics. Now, if anyone's here from California, okay, no. From California, the SB 1380 says you're supposed to divert organics from landfill, and one should separate it, but it does allow for you doing it in this way to keep the organics with the MSW because we need it in the process, and it is a very high diversion of organics from landfill, 99% maybe. It is scalable into different sizes. Lowest size is around 20,000 tons a year, and 500,000 tons is no trouble with that. And this technology is now also available in the US, in North America. It's a German technology available here. We'll go into that. And MYT is not a product. It's not a black box. Like this thing I have in my hand is a black box. Has a certain thing to do, has a certain size, you can't change it unless you're a real electronics genius. You can't change it much. MYT is a process. which can be adjusted to the size, the amount of waste you have, and the kind of waste you have. You do a waste analysis up front to make sure what's coming in there, the whole machine is, or the whole plant and process is designed for this waste. The process steps are waste acceptance in the tipping hall, mechanical preparation, biological conversion, biological drying, mechanical material separation, just 5 steps. We won't go into these in depth right now, but if you look at it, the different 5 steps from left to right, it's like a good piece of prose. Anyone who's a writer and does different paragraphs, you know the last sentence of the one paragraph leads into the next paragraph. It's just like this. Each step prepares the next step for what it's supposed to do correctly. It's a different process in here because the whole thing is a mechanical, biological, yes, there's some chemicals, thermal process. It all works together. That it has to work. You have to know the process, but it's not rocket scientist. No rocket science in here. You don't have to be a super PhD to run this. You have to know the process, though, what's going on. And we make RDF and biogas out of it. I'll talk a little bit about that later. If you look in Germany right now, this blue box on top is how they do it in Germany. Quickly, you will have a black bin or gray bin, whatever you want to call it, for your household waste, MSW. There will be very often an organics bin. All the nice juicy kitchen scraps go in there. You will have a packaging where you could put your PET bottles that aren't reusable back into there. You can put your yogurt things in there, your chips bags. I don't know if we have any flying around here. All the packaging. The green bin, you put your paper, cardboard, newspaper, cartonage, all in there. Yes, you shouldn't put the greasy pizza box in there, but it does land in there. And also downtown, you'd have a place to put in your bottles that you can't reuse and bring them back like they used to have with the Schlitz and whatever blue ribbon beers in the half-liter or pint bottles. That's the way they do it in all of Germany. At Sack, at the Zweckverband in Ringsheim, Germany, at that one plant, we do not have that bio bin. The bio waste, or the organic waste, they call it bio bin there, the organic waste is part of the recycling, is part of the black bin, where they only have to pick up that black bin at your house, and the other things as well. It saves one more card out there, having to be picked up, and as you've probably heard from the SWANA, the Solid Waste Association of North America, waste collection, waste industry is one of the 6 most dangerous jobs in the US right now, sadly. It could be better. So if you keep one less truck on the road, there's a reduction of possible accidents that can happen. This way they do it in Germany. If you don't want to do it this way, okay. A plant can be designed to do it just the way they do it in Ringsheim, or take everything. It can be designed to fit the whole gamut of this kind of waste. This is what the input hall at the SAC plant in Ringsheim looks like. You're seeing on the back left, those are scrap cans that are brought in there for recycling. That goes to a scrap dealer to bring them out. And every day the floor is not completely cleaned, but it's cleaned well enough. And all buildings are under negative pressure. Hall 2, the mechanical pre-treatment, it really looks like this. The floors in the Hall 2 to 5 are every day as clean as this floor is in here, all the time. This is the biological step in these large tunnels where we mix that waste that has come through the next step or the previous step with processed water, not fresh water, so Californians would like that because you're not using a lot of fresh water from anywhere, which they don't have anyway, sadly. Using the processed water in here to create the slurry, which then goes to a press, and the solids go here to the biological drying step, which consists of large tunnels about 30 meters long, 5 meters wide, 5 meters high, and these we pump the whole air through these tunnels, like the building air in here, through these tunnels, and because there's organic still in this material and there's water on it, it starts to heat up, decompose, starts to dry off, and we suction off that air, turn it over once into another tunnel, so after 2 times 4 days, not weeks or months, 2 times 4 days, we bring the moisture content of this material from about 45% down to maximum of 10%. So a little bit moister than some of your paper here or newspaper that's been sitting outside in the Florida air overnight. This is what some of the outputs from the step 5 look like. We will have minerals or inert materials here, different size RDF and lower calorific RDF. We can size it the way you need. The outputs is a biogas, typically 70 to 71% methane content all the time. Not fluctuating, a little bit, but not a lot. And it's continuous uniform production of the methane. And it's approximately 7% of the original input weight that is being produced. So this plant in Germany that we have, which is 100,000 tons a year, we produce around 7,000 tons, metric tons of biogas. Of course, converted into norm cubic meters or whatever units you'd like to use. But it's about 7%. It is utilized correctly. It can be converted to RNG, renewable natural gas. It can be converted to diesel fuels. We've heard that also today, to diesels. It can convert it to a green hydrogen. Some might say gray hydrogen. We can discuss that later on. And it can be used thermically used for creating electricity and heat, which they do at the ZAC plant in Germany, and also converted to a cryptocurrency. Huh? How's that work? I heard this at a biomass conference just last year. Anything, if you take excess energy, for example, from wind turbines, or maybe from here, if you don't have an RNG pipeline close by to such a plant, excess energy from those places, instead of just letting it go somewhere or not using the wind turbine if it's turning at night and the FPL or Duke Energy doesn't need it, you can put it into these server boxes and they will supply the servers with power so they can mine cryptocurrency, mining it using surplus energy not from the grid. Interesting idea. Whether cryptocurrency is something we all want to go with, I'm not going to touch that can of worms. The outputs also with the RDF, refuse-derived fuels, very dry, 90% dry always. High calorific values, it's size dependent. The larger the size, the more plastics there are in there, the higher the calorific value. Somewhere between 9 and 22,000 kilojoule per kilogram, or if I do my math correctly, about 3.9 to 9.5 BTU per pound. Someone correct me if I'm wrong on that. It can be utilized as a renewable resource, making it from MSW. It can be changed to chemicals, RDF to methanol processes. We heard the name Enerchem before. They could use it. It can be burned as well. In the cement industry, direct in the kiln of a cement kiln factory to produce, give them extra heat, having them using alternative fuels, and they like it because the chlorine contents are less than 1%. Usually around 0.5, 0.65, depends on your input materials. Used in power plants, can be co-burned with coal. As I said before with NIMBY, and coal burning is going down in the US, which is probably a good idea anyway. You can have RDF power plants. Of course, you have to clean the air for emissions according to EPA standards or rules and regulations. And the resulting fly ash, also from other different processes, can be used in a product. It's a building product called Appstone. I can give you some more information on that later on. But please, do not landfill RDF, refuse-derived fuels. It's just too valuable to bury. You're throwing away energy. Don't even landfill MSW. You're throwing away a resource, an energy source. Other outputs, metals, bring them to scrap dealers, sorting by type. Minerals, stones, use them, put those on landfill. It's around 10% of the original weight. Depends on your stuff. Or maybe use the stones and glass and porcelain chips, bring it back into the circular economy, possibly, or as a road, underneath a road, if it's qualified to do so. It is clean enough to landfill. That's not the timing. Take out the glass, sort it by color. Use the plastics. It is an enhanced MRF. It can be utilized and removed and sorted by type, 1, 2, 3, or 4, or extracted and used in other high-quality pellets and other things we've heard about today already. Thoroughly utilized, chemical conversion. Unsorted can be used as a concrete filler, something interesting as well. Processed water coming out of it, it's used in a conversion step. Treated processed water is used there and can be also brought into the local sewage treatment plant and eliminates use of the fresh water, possibly as a fertilizer, maybe in arid regions where you want to enhance the ground, but I don't really want to put that stuff on my tomatoes at home. And clean enough for the local sewage treatment plant. They want to know that they're going to be getting that stuff, but they can clean it well enough. And can be used in the chemicals, RDF to methanol processes. For example, Enerchem could use it there. Because of time, we can't get into this too deeply, but the RDF is around 38%, biogas around 7%. Cost to a citizen. A 4-person household in the Ortenau County in Germany spends only 91 euros, or about $110 a year, for the complete process. There are reference facilities, the one in Germany. There's one in France, in Henning-Beaumont, 300,000-ton facility in Bangkok, Thailand, and a few others, smaller ones there. And we're looking to bring more into the States, into North America and Canada. We'll say thank you right there. Because of time, I'll have to cut it short. But thank you very much. If you're interested, we can talk later on. I have some cards. I can also show that if you want to see a brochure on that, take a look, and also look at the website. Go to right there. Anyone? Hold on. There. You can download, click on that. Any questions? We'll save that for later. Thank you very much.
So you may not want to leave